Good day. Today we will be looking at the November 2022 paper 2 question 9. Okay, let's take a look at our first question here. It says, in the diagram, O is the center of the circle. OD bisects chord AB. Prove the theorem that states that the line from the center of the circle that bisects a chord is perpendicular. So they're wanting us to prove that OD is perpendicular to AB. So this is a proof question. And a proof question, this question is 5 marks. So you can easily score 5 marks in your paper if you just know how to prove. Okay, so you know that in your paper 2, they will have this printed out in your question booklet. So it will involve you having to construct. Okay, so I'm just going to construct for the purposes of this video on this paper, and I want you to remember that you must construct. Okay, so the first construction that we need to make is that and make sure you state your construction as well. So the construction is that we need to draw OA and OB. So we need to connect the points so that we have triangles. Because how are we going to prove that this is perpendicular? We're going to prove that this angle and this angle is equal, making them 90. Okay, and in order for us to do that, we need to prove that the triangles are congruent, and we need to make the triangles by drawing these points. Okay, so we have constructed those points. That was step 1. Step 2, it's important now that you say that in triangle ADO and triangle triangle BDO. Those are 2 triangles that we're working with, ADO and BDO. The first thing that we're going to do is we're going to say that OA is equal to OB. Why? Because they are both the radii. OA is equal to OB. They're both coming from the center of the circle to the edge of the circle. So they're both radii, they're both equal. The next thing that we can do is that we can say that AD is equal to DB given. That was given to us. And the last thing that we can do is OD, because OD is common within both of the triangles. And that is a common side. So now we can say, therefore, triangle ADO is congruent to triangle BDO, and our reasoning is side, side, side. And if that is true, and ADB is the straight line, they told us, we know that the ADB is a straight line. Okay, so ADB is a straight line, that's shown. Therefore, angle D1, because we just proved congruency, angle D1, which we should write in so that the examiner knows exactly what we are talking about, D1 and D2, is equal to D2. And if they are equal on a straight line, that makes them equal to 90 degrees. And we know this now because they are congruent. So make sure you state that they are congruent, which is why they are equal. And if that is so, therefore we have proved that OD perpendicular to AB angles on a straight line. Okay, so this question was 5 marks. We'll come to the end about mark allocation, but it's a lot of marks just for being able to prove this. Okay, let's move on to our next question. Okay, 9.2. So it says, in the diagram, E, B, F, S, and P are points on the circle centered at O. I always say mark your center, so you know that this point is your center. Okay, GB is a tangent. Okay, so as you can see here, we've got GB, which is a tangent to the circle at B. FE is produced to meet tangent at G, OT is drawn such that T is the midpoint. Okay, so you can see ET is equal to TF. Okay, GO and OB are drawn, BS is drawn through T, and we've got parallel lines. I always say it's important to highlight your parallel lines because they give you a lot of information. To GF. Those two are parallel lines. Okay, let's take a look at what they're asking us. So the first question says, prove giving reasons that O, let's take a look at what they're talking about, OTBG is a cyclic quad. Okay, how are we going to use that? So in order for us to prove cyclic quad, we can use angles in the same segment. We could also use opposite sides are supplementary, but I don't think opposite sides are supplementary would be relevant here because how are we going to prove that without any angle being given to us yet? So let's try angles in the same segment, because what do we know here? We know that angle OTJ, which is here, is 90 degrees. Okay. Let's also highlight what we're proving. We're proving that OTBJ is a cyclic quad. Okay. And I just said, if we can zoom in here, I said that this angle T here is 90 degrees. And why do we know that? Because the radius is coming to this midpoint of the chord. We know that ET and TF is equal. Then this angle here is 90. Okay. I'm going to highlight again. So OTBJ is what we are trying to prove. I'm going to take out the parallel line for now because it's not relevant to this question. Okay. So let's write that down. So we know that OTJ is 90 degrees. And we said the reason is line from the center to the midpoint of the chord. Okay. Now if we can find another 90, we can prove angles in the same segment. What other 90 do we have here? We know another rule with the center. We know that tangent is perpendicular to a chord, and we have a tangent, and tangent is perpendicular to the radius. We have the radius going to a tangent. So this angle here, they said BJ is a tangent. Here's my radius. So this angle here is also equal to 90 because tangent is perpendicular to the radius. Okay, so that angle is OBJ is equal to 90 degrees, tangent perpendicular to radius. Okay, now are these two in the same segment? Let's take a look. Let's take out this and let's see if we draw a segment. So here, yes, they are. If we look at this segment here, remember, for it to be in the same segment, it needs to be both on the same side, like at the bottom, or at the top, So if we're looking at this side here, you can see at the bottom. So they are in the same segment. Therefore, we can say OTG is equal to OBG, which is equal to 90 degrees. Therefore, the question said OTBJ is a cyclic quad, and the reason that it is a cyclic quad is because we can say converse angles in the same segment, because we're proving backwards. Normally we get given a cyclic quad and we have to prove that we have to show that there's angles in the same segment, but here we're showing that there's angles in the same segment, therefore this has to be a cyclic quad. Okay, our next question, 9.2.2. okay, I'm going to remove the segment. I am going to put our highlighted parallel line back, and we know now that that is a cyclic quad. Okay, it's a cyclic quad. So let's see, how are we going to prove that angle GOB, where's angle GOB? GOB, so this angle here is what we're wanting. Let's use a different color. GOB, so this angle here is equal to angle S. Let's work with what we have. We have the parallel lines, and now we can see that it's going to be used because it's by angle S. Which angle is also equal to angle S? We can say BTG, okay, because you can see here, if I erase the cyclic quad, this line we've got corresponding, so this line here, BTJ, is equal, corresponding angles, parallel lines. Remember, with corresponding angles we're looking for the F shape, and we can see the F shape here, it's going down. So the above the line and above the line is both equal. Okay, so angle S is equal to BTG. Remember, always when you're stating a parallel line rule, you must state the parallel lines. So GF is parallel to PS. Okay, now how are we going to prove that that is equal to that? I have drawn it a bit too large, so we might not be able to see what I'm saying, but if I zoom in, and it is this angle here, what can we see? A segment. Okay, can you see? Because we proved that this is a cyclic quad, this angle is therefore equal to that angle because they're in the same segment. Okay, I hope you are able to see those segments. So therefore we can say BTG is equal to GOB, and our reason is angles in the same segment. Therefore we can conclude that GOB is equal to angle S. Okay, and that was 14 marks for just question 9. Let's take a look at our mark allocation. Okay, the first thing, 4 marks for this last question. For your statement, your reason, statement and reason, 4 marks. The previous one was 5 marks. Statement, reason, and then your answer is reason, 5 marks. And then our proof, we did the proof. And the proof was also 5 marks. 1 mark for your construction, so that's why I said the construction is vitally important. The second mark was for first pair of sides being equal. The other 2 pairs get another mark, and your reasoning. So that's 3 marks for this proof, and then your last mark is for your answer reasoning, 5 marks. So it's a total of 14 marks for this question.